Hello, welcome to the video series on current electricity. In this video, we are going to go through some definitions of terms that will help us to understand the terms that will be used as we go along in this video. So let's start. The first term we are going to look at is voltage. So we are going to come across this a lot in this video series. Voltage, what does it mean? It is also called potential difference. Potential difference. So this is the work done. Per unit charge from one terminal to another in an electric circuit. So work done per unit charge, that's the main thing you want to get there. It means that voltage or potential difference, V, is the work done per unit charge. So it is measured in volts. So that means the unit is volts, small letter V. It is denoted as V. The voltage itself is denoted as capital letter V, but it is measured in volts, small letter V. It is measured that way using a voltmeter. Okay? So we want to measure it. We want to measure the amount of voltage between one end or between one point and other. You just have to connect a voltmeter across the terminal. So by definition, voltage equals work per unit charge. So where V is voltage, W is work done, and Q is electric charge. So electric charge is in coulombs. You see it written as capital letter C. Voltage is in volts, and W work is in joules. So the unit of voltage V is in volts. Okay, so that's one definition. Then another definition will be, this is the first one. The second one will be current. So current is the rate of flow of electric charges through a conductor. Basically, this is the rate at which electric charges flow. So when I say electric charge, what do I mean? I mean the electrons, the negatively charged particles that move around when there is a potential difference. You know, there will be current flow whenever there is a potential difference between two ends in an electric circuit. So current flows due to potential difference, just the way liquid flows whenever there is a pressure difference. So water flows or liquid flows from region of high pressure to region of low pressure. So similarly, current flows from the region of high potential to region of low potential. So if you look at the definition of voltage, I said it's potential difference. That means there will be a region of high potential and there will be another region of low potential, and there will be flow of current from the region of higher potential to the region of lower potential. Take note of that. current flows from region of high potential to region of low potential. Okay, it is denoted as I, as big I, measured in amperes. So there's capital letter A. So the instrument for measuring current is ammeter. It can be measured using ammeter. So we see the symbols for these instruments later on. So I said by definition, current I is the rate at which electric charges move, basically. So rate, it means charges divided by time. When you hear rate, it means something is being divided by time. So this time around is charges, Q. Electric charge is denoted as Q. You can see it here. The rate at which the charges move is current. So from here, if you make Q the subject of the formula, you can see clearly that Q will be IT. That means the electric charges will be current multiplied by time. So Q is measured in coulombs and T is in seconds. Okay. Then another definition we look at will be resistance. So this is the opposition to the free flow of current offered by a conductor. So every material has resistance. Every conductor has resistance. So the higher the resistance, the higher the opposition to the free flow, the more difficult it is for current to flow through that material. Okay, so a measure of that difficulty is the resistance. So and why is that the case? Because current constitutes electrons constitute current flow. In metals, they are delocalized electrons. Those electrons are free to move around. So as they move through the material, they tend to collide or be obstructed by the other particles like protons in the material. So the obstruction offered by the other particle is what is responsible for the resistance. So it's not easy for the electrons to flow through. And as a result of this, as the electrons struggle to flow through, then it increases, there's heat generation, basically. So then the material gets hotter and hotter. So the temperature increases. So the higher the temperature, the higher the resistance. So as we are still going to look at that later on, the factors that on which this resistance depends. But for now, resistance is the measure of the position. Then it is measured in ohms. So this is the symbol, the Greek symbol, ohms. So there are different ways in which you can measure resistance in the lab. But we'll look at that later on. There are different types of resistance. There are two kinds of resistance. Okay, the material that offers resistance is called a resistor. There are two types. We have standard resistors. We have fixed resistance values. And this is the way, let me just give you the symbol quickly. You see it like this in circuits, or you see it like this. Or you see it like this in circuits. You also have variable resistors. Variable resistors, the resistance value can be varied. So this is what we usually use in experiments. So when you want to vary the resistance and determine the corresponding value of the current. So like in the verification of Ohm's law, you use a variable resistor. So you have it like this. So you see it like this, or you see it like this, cross like. So variable resistor. Then we also have conductance. Conductance is the opposite of resistance, basically. So conductance is the measure. This is a measure of the ease with which current flows through the conductor. Okay. So the unit of measure is before I go there, it is the reciprocal of resistance. It means conductance equals 1 over resistance. So the symbol is G, is denoted as G. So G is 1 over R. The unit of conductance is Siemens S, or MHO, whole. It's just, you turn the symbol, the Ohm symbol upside down. Okay. Then we also have resistivity. So what number is that? Have a look. Okay. Resistivity. So that'll be number 4. Resistivity, the measure of the resistance of material of a given conductor. Is a measure of the resistivity of the material of a material of a given dimension. So which means if you state the dimension of the material, the length or the cross-sectional area, so then the resistivity can be determined when we know the length or the the cross-sectional area. You might be wondering what's the difference between resistivity and resistance. There's actually a difference. Resistivity is a property of a material that depends, it measures the opposition to the flow of current, but it depends just on the temperature. So when temperature increases, then the resistance will increase. So it depends just on the temperature. But for resistivity depends on temperature, on the length of the conductor, and on the cross-sectional area of the conductor. So we'll look at that later on, the relationship between resistance, length, cross-sectional area, and resistivity. Okay. So the unit of resistivity is ohm meter, measured in ohm meter. Ohm meter. That's ohm. Then we also have conductivity. This is the reciprocal of resistivity. Measures the ability of a material to allow flow of electric charges. Three. So it's just a way of knowing how easy the material can flow through it. How easy electric charges can flow through the material. So it is the inverse of resistivity. So the symbol for resistivity is rho. Symbol for resistivity is rho. By conductivity is sigma, is 1 over rho. Okay. So that's it for the video. I hope you gain 1 or 2 things from that. We'll stop there and I will see you in the next video.